We're going to use this to reuse our constructors in a class in this screencast. And we're going to start out by creating a new project, and we are going to create that project from the command line app template. We're going to call this constructor example. The first thing that we're going to do is we are going to go in here and add a new class by right-clicking on our package and selecting Java class, and we're going to call this dice. Our class dice is going to have a single attribute, and we're going to call that app attribute value and assign the data type of int to hold the value of our dice. We're then going to create a single constructor to begin with, and it's going to take a single parameter, namely the initial value of our dice, and then we're going to assign this value to the value attribute, and in this way the user of our class dice is able to specify a starting value for our dice. So we can go over here and we can declare a new variable of type dice, call it d1, and assign it a value that points to a new object of dice and give it some arbitrary value. Then we could demonstrate that we have indeed assigned it a value by writing the following line of code where we print out the value of the value attribute. So we can go ahead and execute this code, and hopefully what we would see is that we get the output of 6, which is indeed the value that we sent or passed through our constructor call. Now, we could imagine cases where we don't care about the starting value of our dice. So we could create another constructor that doesn't take any parameters. And in here, what we could do is we could assign value, an arbitrary value, say 1. So in cases where the user of our class don't care about the starting value of the dice, they can just call this constructor down here, and they'll get a dice that has a starting value of 1. And go ahead, of course, and demonstrate that by calling or declaring another variable down here of type dice, give it a new name, and then call our new constructor that doesn't take any parameters. So if we were to print out the value of the value attribute in the object that d2 points at, hopefully what we will see is that it would print out 1 as a value for that one. So let's go ahead and check that. So here we have 6 for the one where we specified the starting value and 1 for the one where we didn't. Of course, this is a viable approach, but it does come with some weaknesses. One of the things we try to avoid when writing code is replicated code. And essentially these two lines of code, they are replicated because the only difference between them is that this one down here represents a specific instance of this statement up here where the value is 1. We can utilize this using this keyword to invoke the constructor up here and passing it a value of 1. Now functionally, this code that I've written here is exactly the same as the code that we had before where we assigned the value up here directly. And we can demonstrate that, of course, by executing our program again and observing that indeed the output of the program is the same as before. This approach here, however, does have some strength that the other one doesn't. For one, of course, we eliminate the need to replicate code. So we are reusing this line of code down here by invoking the constructor using the this keyword. But there's also some other advantages to this, because if we were to add a new attribute up here, say that we would like to be able to assign a name to our dice, what we could do down here is we could say this.name equals no name. Of course, this would be the case if they call this constructor here where we haven't passed a name value. And now this one down here would immediately benefit from this one, the modification up here as well, as it is invoking this constructor up here. So if we were to write out the name as well of our dice, we would hopefully see that in both cases what we end up with is no name for dice in both cases. So let's go ahead and see if that is the case. No name, no name. Of course, we would like to be able to specify a name, so we could actually add another constructor here that takes 2 parameters, namely a value and a name. And then down here, what we could do is we could assign the name attribute, the value of the name parameter, and we could assign the value attribute, the value of the value parameter. Now, down here we see then that this one is more or less a replication of this one up here. So would we be able to actually chain this one to this one as well? Well, as a matter of fact, that would be completely possible. The only thing we need to do is we need to pass on the value of the value parameter up here as the first parameter, and then in the second parameter we would specify no name here, and then functionally we would have the exact same behavior as before, only now we have 3 constructors. So now I could also opt to create a new dice object pointed towards by d3, and then we could say system out println d3.value, and we could go ahead. Oh, and of course here we need to use the new constructor. So here we will say that the starting value should be 4 and the name should be dice1. Down here we could then write system out println and then write d3.name. So now we're using 3 different constructors to create a dice object. Each of them we have a different degree of control as a developer that we want to take on the dice. So here we don't care about the starting value, nor do we care about the name. Here we care about the starting value, we don't care about the name, and down here we care about both things. So let's run this code and see what happens. And hopefully we'll see no name for the 2 first, and then dice1 as a value for the name parameter in the third case. So here we've learned how to chain together constructors using this keyword, and we've also learned how this enables us to reuse code so that we don't have to write the same code multiple places.